A quantity that has both magnitude and direction is a vector, represented by an arrow. The arrow's direction is the direction of the quantity, and the length of the arrow indicates its magnitude. Displacement, velocity, and acceleration are all vectors. Ordinary quantities such as time and mass are scalars. The magnitude of a vector is also a scalar. With vectors, even the most familiar mathematical operations acquire an entirely new meaning. For example, when two vectors are added together, the sum isn't merely a number, it's a new vector.
Okay, what we want to do is take this vector and break it into its x and y components. The way we do that, we have the vector here, and we put our x and y axis at the beginning of the vector, like that. This is the positive x-axis, this is the positive y-axis. Then what we want to do is we want to create a triangle with this, where the vector is the hypotenuse. So I'm going to make a triangle. It's going to be a right angle triangle. And I got my two sides like this. I double check that this is parallel with the x-axis and this is parallel with the y-axis, so I have the right triangle. I also want to make sure I have the direction of the arrows correct. The start of the vector is here, the end of the vector is there. So my arrows must go from start to finish in a continuous path. So this goes there, this must be to the right, and this must be up. Now I need to calculate the magnitude of these two components. And that's quite easy. We're going to memorize that if this is 30 degrees here, that the adjacent side is going to be my cosine. So this will be the vector 8 times the cosine of 30 degrees. So my AX is going to be 6.9. It's to the right, which is positive. My y side, it's the sine side. So what I remember is it's going to be 8 sine 30. So AY is going to be 8 sine 30 is 4. And it's to the right, so it's up, so it's positive. So my AX is positive 6.9. My AY is positive 4. Now I have the two components. I've checked them that they've got the sign, and the sign is correct, to the right. So x is positive, up, y is positive, I'm done. I have the two components of this vector.
For example, you may be faced with a question like this. A bird takes off from the ground at a 30-degree angle and lands on a tree branch exactly 50 meters away. How far did the bird fly with respect to the ground? How high is the branch? The bird flew exactly 50 meters, but because the bird flew at an angle, the distance on the ground, meaning if you were to follow under the bird as it flew, would not be 50 meters. Let's represent this with a diagram. The ground will be our x-axis, and the bird takes off at 30 degrees, so our angle is 30, for a total distance of 50 meters. If the bird lands on a tree over here, if we're following along on the ground, we would have walked something less than 50 meters. And if we want to know the height of the branch, that'll be significantly less than 50 meters. Now, even though this isn't drawn to scale, you can get some idea that the x distance will be closer to 50 than the y. So how do we figure out the x and y components?
Vector algebra makes use of two perpendicular unit vectors, I and j. The little hat over the vector means that it has length 1. The vector from the origin to the point with coordinates x, y is the sum of two perpendicular vectors, a horizontal vector xi and a vertical vector yj. With the help of I and j, adding and multiplying vectors can be accomplished by ordinary algebra. In three-dimensional space, a third unit vector k is used. K is perpendicular to the plane of I and j. A three-dimensional vector is written xi plus yj plus zk.